Welcome to RGES Algebra 2. This is Lesson 18A. We're starting a new unit called Variation and Dependence. And if you begin your, if you grab your book and you look on page 118, we are going to cover several of these objectives in this first lesson. It says, understand the concept of dependence in everyday situations and in algebraic expressions. Identifying the variable and the constant in an algebraic expression, understanding the relationship of one variable to another in the same expression, and understanding the difference between independent and dependent variables, and using a symbol to represent a function, and understanding the concepts of domain and range. So over half these objectives will be covered in these first two sections. So we are going to begin by looking at either what we call a formula or an equation. This formula you might recognize. This is how we convert degrees Celsius to degrees Fahrenheit. Here. So we're converting degrees Celsius to degrees Fahrenheit. And this is the formula. Well, we have two variables. Our variables, and hopefully you do recognize what a variable is. It's a letter that represents a value in algebra, and our variables are F and C. Our constants are only numbers. Sorry for that terrible writing there. Constants are numbers, and in this case our numbers are 9/5 and 32. This is a 5. Okay. So that part is fairly straightforward. I would expect you to know that from your previous algebra understanding. But now we're going to divide our variables into two types, what we call the independent and the dependent. And wherever you have a variable equal, the variable equal, and it's isolated by itself, on the left-hand side, this is my dependent variable. The other one on this side of the equation, where you have a variable in here, maybe several variables, these are called my independent variables. Why? Well, go back and look to my expression here, or my formula up here. I choose values. I get to choose the values for C, and I calculate the value for F. So the ones I get to choose are my independent variables. I choose them. I decide anything I want, and I plug it in, or anything I'm, wondering about in a problem. And then the one I calculate is called my dependent. Calculate because it depends on the values that I plug in here. So independent, so it's kind of a logical idea, I think. All right, so open up your book to page 119. I would like to step through these first several problems together. On number 1, it says D equals 70t. It shows the distance a driver can drive at a constant rate of 70 miles per hour for t hours. The distance is dependent on what? Here's my distance. It's dependent upon the value of t, or time. The answer would be time, comma, t, or time t. If t is increased, what will be the effect on D? If I increase my t, and rather than saying I'm driving 1 hour, okay, I'm going to say I'm driving 2 hours. What effect will that have on D? Well, it's going to increase it, isn't it? So D increases would be, I'm sorry. They're asking if I decrease it. I'm answering for increase. Okay, so 1B says if T is decreased, then D will be decreased. D will go down. C, what is the independent variable? That's the one I get to choose. That would be the T. What is the dependent variable? That's the one I calculate. That would be the D. And what is the constant? And the constant would be 70. Let's look at number 2. And this is just kind of, it's really learning vocabulary and just a little bit about how these are related to one another. If you draw 3 circles with different radii, such as 2 inches, 3 inches, and 5 inches, the equation for the area of the circle is A equals pi r squared. So that's my equation or my formula. Compute the area of each circle in terms of pi. So you would plug in 2, and you would get 2 squared or 4 pi. You would plug in 3, you get 3 squared or 9 pi, and you would plug in 5, and you would get 5 squared or 25 pi. A says, the area depends on what? Well, the area depends on the radius. This depends on this. If r is increased, does the value of A become greater or less? Well, what happened here? As this number went up, the 2 to 3 to 4, or to 5, then my answer, or my area, went up. So as r is increased, area increases. It becomes greater. What is the independent variable? What's the one I'm plugging in? The r. What's the dependent variable? What am I calculating? The area, A. And what's the constant? Any number. Well, we know that pi never changes. The value of pi never changes, so pi is a constant. It represents a number. 3, the equation I equals 0.08p represents how much interest a bond will yield annually at 8%. The interest depends upon what? The principal, right? The P, how much money I invest. So I invest, let's say, $1,000. I get 8% of that back as interest. Okay, so interest depends on how much principal I invest. It also depends on the interest rate here, but they've given you 8%. What effect on the value of I will an increase in P have? So if I increase my principal, will the interest go up or down? And hopefully you can see as you're multiplying by a certain number, it will increase. And see, what is the independent variable? Hopefully you see this by now. The one I get to plug in is my principal, or P. The dependent variable, the one I calculate, is my interest, I. And the constant is any number, in this case 0.08. Use the equation V equals E cubed to compute the volume of a cubic box whose side E is 3, 5, or 10. So we would compute it 3 times. 3 cubed is 27, so the volume would be 27, whatever the unit is. 5 cubed is 5 times 5 is 25 times 5 more is 125, and 10 cubed is 1,000. The volume depends on what? on the value of E, or the edge. As E increases, what happens to V? It also increases. The independent variable would be E, the dependent variable would be V, and the constant, there is none, no constant. Okay, let's see what then they want you to do here. So your assignment will just be marching through what is the constant, what is the independent variable, and the dependent variables. So you should have no problem with that now. You also have 2-word problems. Go ahead and work on those, and we'll talk about them together in class if we need to. Now the next concept is talking about a function. The definition of a function is that the value of the independent variable, when I put in a value for the independent variable, I only have one answer or one value for the dependent variable. Okay. So let's think this through. If I plug in my independent variable, a value for that, I will only get one answer, not 2 answers. Well, what could be an equation that is not of a function then? So we'll have some equations. So functions are a subset of equations. Every function will be an equation, but not every equation will be a function. So let's say if I had having a hard time writing here, y equals plus or minus the square root of x minus 6. And let's say I'm going to plug in for my independent variable, my x. Let's say I want to plug in the number 15. So then if I plug that in, my dependent variable will end up being 15 minus 6, or 9. And my answers will be what? What times what equals 9? 3. But I have a plus 3. Y can equal plus 3 or minus 3 because of this. Okay, so this is 2 answers. So this is an equation, but not a function. That's what they mean. Okay, now when you have a function, rather than writing something like y equals 3x plus 2, that would be a function, because for every x value I would only get one y value. So this is a function. So let me make this clear. This is the one that's not a function. Okay. But this is a function down here. For every function, I could write, rather than y, I could write the function of x equals. So this is just a new way of writing it. Rather than writing a y, this shows me clearly that this is a function. And to find the answers, if I would say calculate or find f of x, that's how we read that. Okay. If x equals 3. Find f of x if x equals 3. If I'd written it this way, I would just say find y, solve for y. Okay, so this is just different vocabulary almost, okay? So what would I do? I'd plug in my 3 every time I see an x. 3 times 3 is 9 plus 2 more is 11, so f of x in this case equals 11. Another way I could write that is if I would say if f of x equals that, find or solve for f of 3. Or f of 0 means plug a 0 in for the x. F of negative 2 means plug a negative 2 in. So the first time we already found it. We'd go back to our equation here. We'd plug in 3, and we'd say f of 3 equals 11. For the next one, f of 0, I would plug a 0 in to this same equation, and f of 0 equals 2. And finally, f of negative 2, I plug the negative 2 in, so I get negative 6 plus 2, or negative 4. The last idea they cover is domain and range. Domain, by definition, is all the valid values for the independent variable or variables, and range is the valid values for the dependent variable. Oftentimes that's going to be from negative infinity to positive infinity, but sometimes we would have things excluded. For instance, if I said, let's say f of x equals 7 over x, I cannot divide by 0, so 0 would be excluded from my domain. So you think that through, read through the description of that in the literature, and then do 5.2, the rest of that on your own, and we'll talk about any confusions when you come to class.